Hello folks, welcome back to my YouTube channel. This is Divyanshan, and in today's video we are going to study how a neural network works. Okay, so this is my let's understand it with an example. Suppose I have this a data set, okay, which has input features like IQ and CGPA, and basically I want to create a model. Let's say this is a model, okay. I want to create a model which takes let's say I am providing IQ of a student and the CGPA, okay, CGPA to my model, and I want to predict if the particular student will get placed or not, okay, get placed or not, okay. Basically my model will take a IQ and a CGPA, and it will predict if the student will get placed or not. So over here on the right hand side you can have a look. We have this IQ column, CGPA column, and the output column. Output is I can name this as like placed. So basically over here you can have a look, like we have values like 1 and 0. Okay, 1 basically means the student is placed and 0 means student is not placed. Okay, 1 means student is placed and 0 means student is not placed. So if the IQ of a student is 90 and the CGPA is 9.2, then the student is placed. And if the IQ is 70 and the CGPA is 8.0, then also the student is placed. And if the IQ is 72 and the CGPA is 7.1, then the student is not placed, because we are getting 0 correct. Okay, so we have this data set. Okay, where basically this IQ and CGPA are my input features. Okay, these are my input features, and this is basically my predicted output. Actually, this is my training data set. I am considering it my training data set. Okay, I am talking about what is training data set. What I am trying to say. Suppose this is the input features and this is basically my output. Okay. So basically, I provide these input features to my model, and I want to basically predict if the student will get placed or not. So let's have a look of how this basically can be understood with a neural network. Okay, let me create a neural network for this. So yes, basically we have two input features. Okay, this IQ and CGPA. We can have n number of input features. Okay, based on your data set. Okay, yeah. Suppose we have this input feature. IQ, I am saying it as x1, and this CGPA is x2. Okay, these two I am basically finding out the solution. In my earlier video, I have talked about how what is a perceptron. Okay, how we basically calculate the output. Again, I am repeating in this, and we have this x0. Okay, I have talked about what is x0. X0 is my basically bias. Okay, over here and we basically multiply each of the input feature with some weight, and then we find out the summation of these. Okay, and this is basically passed out to the activation function. Okay, some activation function, and then we get the output, which is a y hat. Okay, y hat is basically our output. Again, I am repeating. I have covered all these in my earlier video. Again, I am repeating. Okay, y hat is nothing but my output, and this is my activation function. Okay, activation function, which basically governs that if my particular neuron is active or not. And this is nothing but it is something like, suppose I can have n number of features, right? This is nothing but this can be represented as like y equals to summation of I equals to 1 to n, and basically I am taking x of n and multiplying it with w of n, and then I am adding this bias of x0. Okay, x of 0 is nothing but it is a scalar quantity. Okay, it is a scalar known as bias, BIS. Okay, this is my bias, and after calculating this y is basically actually let me not confuse you. I am basically using y, not using y over here, because in future I will be using y for some other purpose. Okay, so let's take this as z. Okay, suppose this is my z. Okay, and after calculating this, I have to pass this to my activation function. So basically, that will give my output. So can I like write this as like this? Basically, my y hat, which is my output, is nothing but it is equals to my this activation function. I'm passing my this z inside my activation function. Okay, I can write this as like x0, which is my bias, plus summation of I equals to 1 to, let's say, n, and then x of I into w of I. Okay, this is my actually statement expression of like finding out the output, which is my y cap. Okay, cool. So this is basically my statement. Okay, yeah. So let's see how basically my neural network works. So this was a revision of my earlier video. Okay, let me erase this. Okay, I hope like you have understood the situation. Okay, yeah. So let's create basically a neural network for this. How it will look like. So this is my basically x1. This is my x2, which are my input features. This will get passed to this particular neuron over here, and this neuron will give me basically output. Let's say y hat. Okay, let's understand. So this over here, what some operations will I have shown you just now. I have shown you what operations will happen over here. So this is x0, which is my bias. Okay, over here some operations will happen. Basically, some steps will happen. Like the first step is basically finding multiplying this x1 and w1 with w1 and x2 with w2. So on, if we have xn number of features, xn will be multiplied with w, and right. This process is nothing but we are learning about forward propagation. What we are learning about? Forward propagation. Forward propagation. Okay. We are learning about forward propagation, and we will also be learning about backward propagation. Okay. Forward propagation is like our basically input features are getting multiplied with some weight, and we are adding these, and we are after finding out the summation of all our input features multiplied with some weight. We are adding a bias term, and then we are passing it to the activation function. So I want you all to basically understand this, take this up from this lecture, that to find out this output we need to perform two steps. Okay, the very first step is to find out the summation of these input multiplication of this input feature with this weight and finding out those sums. Basically it's like z equals to, you can say, x1 w1 plus x2 w2 and so on till xn w1. Okay, finding out this summation and adding the bias term x0, which is a scalar. Okay, this is the very first step which you need to perform for finding this y cap, which is nothing but our output. Okay, predicted output. Okay, so first step is to find out the summation. Okay, and after that we have to pass this z inside the z to the activation function. Okay, so we have to pass this to the activation function. Okay, so I can say act of z is nothing but this will give me the output y. Some of the activation functions are like sigmoid activation function, ReLU activation functions. Okay, leaky ReLU. So these are some of the activation functions. We will be talking about these in particular video. Okay, yeah. So this is how our basically how our output is calculated, how our neural network works. So let me show you one more. Basically, a neural network with some hidden layer. Okay. Okay. So we have for this we will be designing a neural network for this. Okay. So we have this. Let's say neuron. And this will be passed to this. Okay, yeah. So over here, let me tell you some terms. So this over here, x1, x2, this can go to till xn, which are basically, I have told you, these are nothing but my input features. Okay, over here in our case we have IQ and CGP as our input features. Okay, so we have x1 and x2 over here. Okay, we can have a number of input features. Okay. So we are providing these two are okay. So these outer ones are known as my input features or input layer. Okay, this is known as input layer, and the one inside this is known as a hidden layer. Okay, hidden layer, and this one is known as the output layer. Actually, the hidden layers are the layers. There can be n number of hidden layers. Okay, the layers between the input layer and the output layer is known as a hidden layer. You can have n number of inputs. Okay, okay. We have something known as hyperparameter optimization, where we find out how many number of basically layers will be having, how many number of neurons will be having. Okay, so this is a neuron, hidden neuron. Okay, this is basically a hidden layer which has only one neuron. Okay, so over here, what how this will be calculated is basically this my, let's say IQ, H1 is my IQ. IQ is multiplied with some weight. Okay, okay. Let me rename these. This is, let's say, IQ, and this my X2 is nothing. It's my CGPA. Okay, let's say this is my CGPA. Okay, so my input layer is basically having IQ and CGPA. So basically, I am multiplying my IQ with W1. And then IQ into W1, and then I am basically adding that with CGPA into W2, CGPA into W2. Okay. After multiplying these two, what we need to do is basically we need to add a bias term. Okay. So we are adding a bias term which is x of 0. Okay, x0. Okay. After that, this basically gets passed to my this hidden layer. After first of all. After finding out this, it is going to be passed to the activation function. Okay, and after passing it to the activation function, let's say this is nothing but it is my z. Okay, it is my z. This entire equation is my z. So this is I. Okay, don't confuse it with z. This is I. After passing this z, after passing it to my activation function, it goes inside this neuron. Okay, after this neuron, this particular output is getting multiplied with some another sum weight. Let's say W3. Okay, from here, let's say this gives activation of Z is nothing but it is, let's say P. Okay, this P is getting multiplied by W3 again, and then again it's getting basically it's getting passed to the activation function and then going to this output. Okay, this is something like P of W3 and passing it to the some activation function and then giving it to the output layer. Okay. And then output layer basically gives me 0 or 1, which basically tells me if the student is placed or not. Okay, again summarizing. So we have basically IQ and CGPA as input features, and place is my output feature. So 1 basically means student is placed and 0 means student is not placed. So this is basically forward propagation which we are studying. So over here we have some neurons. This is my basically input layer where we have this IQ and CGPA. Okay, IQ and CGPA, and this IQ will get multiplied with some weight W1, and we'll add that to CGPA into this some weight W2. Okay, I'll be talking in depth about all of weights, and after finding these IQ to W1 plus CGPA to W2, we'll be adding a bias term. Okay, which is a x of 0. Let's say I'm saying this all equals to z. Okay, over here. And after this, basically, let me clean this. Okay. After basically finding out my z, what is z? Z in this case was this, right? This entire this. So after finding out z, we need to pass it to an activation function. Okay. After passing it to my activation function, it comes to my over here. Okay, over here. These all stuff is happening over here in the neurons. Okay. After passing it to my activation function, it comes to my neuron. And basically this activation function will govern if this neuron is active or not. Okay. After this neuron, let's say we get something known as, let's say, P. Okay. This P will get multiplied with some weight W3, and again this will get passed to some activation function. Okay. Again this will get passed to some activation function. Let's say activation function, and this activation, after this it will get passed to my output. Not there. It will be passed to over here. Okay, and then we get a 0 or 1 placed on that. 0 basically means the student is not placed, and 1 means student is placed. Okay, so I hope you understood this, what is forward propagation, and These W1, W2 will based on the number of input features. If you have X n number of input features, then you will have Wn number of weights, and they are basically randomly initialized. Actually, randomly initialized. They will be randomly initialized, and during the back propagation, these weights will be again re-initialized. Okay, updated basically, not re-initialized. We'll be talking about this, how this basically the weight get re-initialized, basically updated, okay, not re-initialized. These weights will be get basically updated in the backward propagation. Initially, weights will be randomly initialized, okay. So this is something known as forward propagation, as the word says forward. So we'll be moving from this input feature to the output, okay. Whereas in the backward propagation, we'll be moving from the output to the back side, to the input side, basically updating all the weights, like these W3, W1, W2, and so on. How many weights we have? Okay. So I'll be talking in the next video. I'll be talking about back propagation and stuff. So thank you for watching, and if you have any comment, any queries, then you can simply comment. Thank you.